Hello everyone. So today we are going to solve the numerical problems of the exercise of the chapter motion of class 9. Okay, so we are starting off from question number 4. So we start from there and let's see what is the question. If you look into the book, the question says a motorboat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during that time? So let us write what is given in the question. All the things that are given in the question, let us write that down. So here we have question number 4 and let's write what is given. So it says that the boat starts from rest. So since it starts from rest, its initial velocity, that is u, will be 0 because it was at rest at the beginning. Now it moves in a straight line at a constant acceleration of 3 meter per second square. That is, acceleration is given. Acceleration A is 3 meter per second square. Acceleration is given for 8 seconds. 8 seconds means the time here t is 8 seconds. Okay. So these are the things that we have. How far does the boat travel during this time? So we have to find the distance. So how to find the distance for this in this case? So if we look here, we have u, a and t. Which formula do we know? We have 3 formulae, right? So one is v is equal to u plus at, one is equal to s is equal to ut plus half at square, and the other is v square minus u square equal to twice as. So these are the 3 formulae that we have at our disposal. So now let's see, I want to find distance, there is s. So if I want to find distance, which formula I will use? Obviously this one, because here we can find s using u, t and at, means u, t and a. See, I have u, t and a. So let us use this formula. We have all the values, we can find the value. So therefore s is equal to ut plus half at squared, where u is 0, it is given 0, t is 8 plus half into acceleration is 3 and 8 squared. So this will become 0 plus half into 3 into 8 square is 64. So if we cancel this out, 32 into 3 is 96. So it is going to be 96 meter. Distance travel 96 meter. Very simple. Select the formula. See which values you have. Once you know which values are there, you will know which formula to use. Because if I wanted to use this formula, suppose, then in this case I want to find s. I know acceleration. See, acceleration is given. I know the initial velocity. Initial velocity is given. But I don't know the final velocity v. So I cannot use this formula. I have to use this one because I know all the values here. Okay. So that is how we do question number 4. Let's move on to the next one. That is question number 5. Okay. Let me keep this up here so that we can take help from this. So let's move on to question number 5, and here it is said a driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. That means the car was going at 52 km per hour, he applied the brake in the opposite direction, means obviously it is retardation. Retardation means the decrease in acceleration, means reducing acceleration. So when the car is moving, it applies brake, it comes to a stop. After how much time? It comes to a stop after 5 seconds. So in 5 seconds, the car comes to a stop from 52 km per hour to 0. Okay, the car was moving at 52 km per hour, applies brakes, comes to rest in 5 seconds. And there is another driver who is going at 3 km per hour. The speed was only 3 km per hour, very slow. In another car, applies brakes slowly and stops in 10 seconds. So he was moving at 3 km per hour, he applies brakes really slowly and comes to rest in 10 seconds. So first one was moving at 52 km per hour, applied brakes and came to stop in 5 seconds. The second one was moving at only 3 km per hour, applied brakes so slowly that he came to rest after 10 seconds. So now what is the question? The question is, on the same graph paper, plot the speed versus time graphs for the 2 cars. Which of the 2 cars traveled further after the brakes were applied? So let's see how to solve this one. This is question number 5, so we need to draw a graph. So let us draw this. It is better if you draw in a graph paper. If you don't have a graph paper, then try to take proper measurements using scale. Okay, like for example, I take 1 centimeter equal to 1 kilometer or 1 second. So this will be our speed versus time or velocity versus time graph. It is said it is speed versus time. So this way we will have time along the x-axis, and along the y-axis we are going to have the speed. Okay, so this is direction of speed, this is direction of time. Okay, so now what we need to do, we need to just plot the points. So suppose we have these points, 2 3 4 5 6 4 5 6 7 8 9 10 11. Okay, so we have these values here, and on this direction we need to have speed. Now the speed ranges from 3 km and 52 km per hour. Okay, so let's have something like 5. So if you have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, suppose this is a rough one. So we have 5, 10, 15, 20, 25, 30, 35, 40, this is 45 and this is 50. Okay, I hope it is visible. So this is 50. So now his speed, the first car had a speed of 52 km per hour. So he started from, this is the speed, right? So he was at 52 km per hour. And he came to rest in how much time? Only in 5 seconds. Means in 5 seconds his speed decreased from 52 to 0. So we must have a graph something like this. His speed was 52. After the end of 5 seconds his speed came down to 0. Decrease in speed. Okay. Next one was having a speed of like this, 3. He was having a speed of 3. He applied brake so slowly that he came to rest after 10 seconds. So that means this will be the graph for the second car. This is for car 1 and this one, this small graph is for car 2. Okay, I hope you can see this. This one is 52 km, the first car, in 5 seconds it came to rest, and the second one at 3 km per hour, it came to rest in 10 seconds. So time is in seconds and speed is in kilometer per hour. Okay, so now what do we need to do? What we need is, we need to find the distance. We need to find which one covered most distance after applying brake. How to find distance from a velocity time graph? If you find the area of the triangle, you can find the velocity of the graph. So velocity, I mean distance traveled by the car. So why we can find, what is the formula of the area of a triangle? It is half into base into height. What is the base here? This is the base. What is base? Base is the time. That means half into time. And what is the height? Height is the speed. And do you know what time into speed is? Time into speed is distance. Okay, so that means using this formula we will be able to find the distance traveled. Okay, so let us try to find this one. Okay, so for the first car, the distance traveled is equal to half into base. What is the base? Base is only 5 seconds. Into height. Height is 52 km per hour. 52 km per hour. That means we need to convert it to seconds. So meter per second, SI unit. Because this one is in second. So let us convert this to second as well. 52 km per hour means 52 into 1000 is 52 meter. And hour means 60 into 60 will give us seconds. So this is going to be this much meter. So now we need to find the value. So it is 0 0 will go, 0 0 goes. So here at the bottom we are going to, okay, this one can be written as 26. 26 into 5 is, okay, let's keep it 5 into 26, and at the bottom we are going to have 36. So 2 18 and 2 13. So 5 into 13 is 65 by 18 meter. Okay, so it is 65 by 18 meter. Let's write it in mixed fraction, it will be easier. 18 into 3 54 and we have 11. 3 and 11 by 18 meter. This is the answer. The answer is 3 and 11 by 18 meter. That is for the velocity, the distance traveled by the first car. Now we have to find the distance traveled by second car. So for second car, the distance is equal to, what is the distance? The distance is, it started from here, so it is half into base into height again. What is the base? Base is 10 seconds. And what is the speed? Means height is only this much. This is 3 seconds. So it is 3. But 3 is what? Kilometer per hour. So you have to convert it again to meter per second. So it is going to be 3 into 1000, 60 into 60. So what is going to be the answer? 0, 0 will cancel out, 0, 0 cancels out. 2 here, we get 5 here. At the bottom we have 36. And at the top we have 15. I mean 5 into 3 into 10. 3, 1 and 3, 12. So it is 50 by 12. So it means 12, 4 and 2. So this one is 3 and 11 by 18 meter. This one is 4 and 2 by 12 meter. That means the second car travels more distance. It is 4 and 2 by 12. And this one is, okay, I think we need to do one thing. We can do one thing here to get it even more clear. 2 into 25 and 2 into 6. So again here 6, 4, 1. 4 and 1 by 6. Better option. So 4 and 1 by 6 and here 3 and 11 by 12. So obviously 4 point something is going to be more than 3 point something. So therefore car 2 travels more distance after applying brakes. So that's how we do question number 5. Now let's move on to question number 6, and question number 6 seems a bit tricky because the graph given is very complex. So okay, what I will do here is I will add one graph right here so that you can see the graph which is given in the book. So I will be applying one colorful graph so that it is easier for you to understand. So here, if you see the graph and you look at the question, it is said that it is a distance time graph. So on the y-axis it is distance and towards the x-axis it is time. So a distance time graph, and there are 3 objects A, B and C, and each have different graphs. So by looking at this diagram, we need to say that which of the 3 is traveling the fastest. So if you look into the graph here, this is number A, this is number 6A. 6A asks which one is moving faster. So we need to see, in order to see which one is moving faster, we need to see which one travels the most distance in the least amount of time. If you can travel more distance in less time, that means your speed is more. So if you look at B, B has traveled almost 12 kilometers. A, B and C all have traveled the same distance. As you can see in the graph, their level of distance is same. So if you look at how much time they have taken, B has taken the least amount of time. Okay, B has taken the least amount of time, then we have C, then we have A. So as B has taken the least amount of time and the distance traveled by B is also largest. It has started from 0, if you see in the graph, it has started from 0 and it has moved up to close to 12. So from 0 to almost 12 is the longest distance covered, because if you look at C and A, they have already started above 0, means they had already covered some distance. So we are not going to calculate that distance. We are going to see from where it has started. Okay, but B, as we can see in the graph, the longest line is of B. That means B has traveled the most distance. Plus it has taken the least amount of time. That means B is the fastest moving object. So the answer here is B. B is the fastest moving object. I hope you understand this from the graph. Next, are all 3 ever at the same point on the road? No, they are never. If you can see the graph, you will see that all the 3 lines never match at the same point, because the graphs are like this. One goes like this, then one is moving like this, and the other is moving like this. So here 2 meet, here 2 meet, and here 2 meet. But all the 3 points don't meet at the same point. So that means these 2 lines meet at this point, these 2 lines meet at this point, and these 2 meet at this point. But all the 3 don't meet at any single point. So they are never at the same point. So the number option B, question B is no. They never meet at the same point because all the 3 lines don't intersect at the same point. That is question number B. Now if we look into C, how far has C traveled when B passes A? So this is where you need to do some mathematics looking at the graph. So you look at the graph and you will see that if you look at the graph here, what you are going to see is, and I think it will be better if you look into the in your book, the question that is given, the graph that is drawn in your book. Okay, in your book, if you concentrate, you will see, if you count the boxes, since the graph is given like this in boxes, like this. Okay, so you can see, count the number of boxes. Okay, So count the number of boxes, you will see 4 is written, we have 4, we have 8 and we have 12, right? We have 12. These are the distances. Now if you see how many boxes make up 12 in the book, you will see it takes 7 boxes to reach 4. That means the number of boxes here is 7 boxes. 1, 2, 3, 4, 5, 6, 7. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 boxes make up this distance of 4. Okay, this is 4 kilometer, distance in kilometer. So since we need 7 boxes to cover 4 kilometer, that means what does one box represent? We have 7 boxes is equal to 4 kilometer, right? Therefore, what is one box? One box is equal to unitary method. It is 4 by 7 kilometer, right? 7 comes here. Okay, so here we have that 7 boxes represent 4 kilometer. That means each box will represent 4 by 7 kilometers. So now we know what does one box mean. One box towards the x-axis means 7 by 4 kilometer. Okay, now we can easily calculate. So what it says is how far has C traveled when B passes A. So if you look into the graph, I have it here. So if you look at this graph or the one in the book, let me use the book. So when B passes A, that means find the point when B and A intersect. If you see the point where B and A intersect, you take your book and you see what is the amount in the distance line, means in the y-axis where B and A meet. B passes A, right? So find a point here where B and A will meet somewhere like this. Okay, and try to correlate to what is the number of the box here. Take this line and see which box is here. Okay, count the number of box. So if I see here, the number of box where B and A meet is after 8, it has covered 2 boxes. Okay, 2 boxes it has covered after 8. After 8, 2 boxes. Right? So now we need to see that how much distance has C traveled. So the point in time where B has crossed A. So this is our B, this is our A. Okay, so we have another, okay, let me draw it in a different way without the graphs, bars. So we have B like this, then we have C moving like this, and we have another one A moving like this. So it is B, C and A. Okay, so we need to find how much C has traveled. So we need to find how much C has traveled when B passes A. That means when B passes A, this is the point. So for this, it comes to here. Now if we increase this one, this is the point where C was when B has passed A. I hope it is clear. B is passing A in this point, and at that time C was here. So how much distance has C covered? Count the box here. From here to here, count the number of boxes. From this point to this point, count the number of boxes. If you can count the number of boxes here, so you will be easily able to get what is the distance traveled by C. Okay, so if we see from the graph, if we count the number of boxes C has traveled from this position to this position, where B and C meet, B and A meet. So we need to find C. Count up to here. From this position to this position, count it. So what I get from my graph, it is 4 boxes, 5, 6, 7, 8. Then we have to move to 8, 9, 10, 11, 12, 13. I think it's 13 boxes. Let me do it again. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it is 12 boxes. 12 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So C has covered or traveled 12 boxes. C has traveled 12 boxes. 12 boxes means each box is 4 by 7. Sorry. Therefore, distance traveled by C will be 12 into 4 by 7 kilometer, right? 12 into 4 by 7 kilometer is how much? 12 into 4 is 48 by 7 kilometer. All right. Now this is not it. Why this is not it? Because this is the distance traveled what is given in the graph. So C starts from here, right? Now this part is left. This is also the distance that C has already traveled. So you have to count this part also. So what is this part? This part means from here to 0. So how many boxes? We have 1, 2, 3 and 4. 4 more boxes. So 4 more boxes means what we can do, don't do it here. What we will do now, C has traveled not 12. 12 boxes here and 4 boxes here. 12 here and 4 here. That means how many boxes? 16 boxes in total. 12 plus 4 is 16 boxes. So for this region it is 12 boxes, but for the whole it is 16 boxes. Therefore distance traveled by C is actually 16. One box is 4 by 7, so it is 16 into 4 by 7 kilometer. So 16 fours are 64 by 7 kilometer. This is the distance traveled by C when B passes A. So what we did here, we found out the point where B and C meet, and we found out in which line it coincides with C. So once we found that line, we tried to find out this value. Then what we do, we find this whole one. Okay, we count the number of boxes from 0, how many boxes it needs to come to this point. So there are 16 boxes. 16 into 4 by 7 will give us the total distance covered by C. So that is the distance covered by C. Now we move on to how far B has traveled at the time it passes C. So now it is easier. How far B has traveled when it passes C. That means we need to find the point where B and C meet. So where do B and C meet? B and C meet here. Okay. So what you do? You find the line that meets the y-axis. So take up your copy or book. Take up your book and see that if you look into the graph where B and C meet. So B and C meet at a point which is above 4, right? Above 4. So you count the number of boxes it meets here. So it is 7, 8, 9. Yeah. So it is 9 boxes. So from 0, if you move from here, this is the point where B and C meet. You move from here. So if you count the number of boxes, you are going to find that it is actually 9 boxes. Okay, so each box is 4 by 7 kilometer. So how far has B traveled? B has moved from this part to this part, right? See, B is from here and then it moves like this. So this is the distance traveled by B from this point to that point. How many boxes? 9 boxes. So if it is 9 boxes, what will be the distance traveled? Distance traveled by B will be equal to 9 into 4 by 7 kilometer, which is 36 by 7 kilometer. So this is the distance what B travels when it crosses C, means when B and C intersect. So all you need to do is find the meeting point and find at which box it meets in the y-axis. Once you find that, you can easily count the number of boxes and find the distance. And this one is important. Since 7 boxes make 4 kilometer, how much does one box make? Once you find this, whatever is the number of box, multiply it with 4 by 7. You will get the kilometer. So that is how we do number 6. Now we move to number 7, a very easy sum. Here it is asked, a ball is gently dropped from a height of 20 meter. So from 20 meter, you drop the ball. Its velocity increases uniformly at the rate of 10 meter per second square. So 10 meter per second square is the acceleration. What is the velocity when it will strike the ground? And second part is at what time will it strike the ground? So let us start this one. Question number 7. So question number 7, it is said that at a height of 20 meter. So if the ball is at a height of, this is the ground, the ball is at a height of how much? 20 meter. This is 20 meter distance. So how much distance the ball has to cover? It will start from here and it will fall down here. That means the distance covered is 20 meter. So it is given, that is height. Height which we will take as distance. Okay, because here we have to use this formula, right? So height is actually the distance that will be covered by the ball. So height is equal to 20 meter. It is given in the question. Why I have taken height as distance? Because that is the distance the ball will travel once it is left from here. If I leave the ball from this position, what distance will it cover? Obviously 20 meter. Okay, so it is taken, S is taken as 20 meter. And it is given acceleration. acceleration is given as 10 meter per second square. Fair enough. We need to find the final velocity. But before we move on to final velocity, what is the initial velocity here? The initial velocity in this case is 0 because the ball was we are holding the ball at the top. The ball was not falling from above. We are holding the ball here and we leave it from here. So since we are holding it, that means it was at rest, and rest means what? 0. So initial velocity that is u was 0. We need to find what? We need to find final velocity. To find v, we need to find v. So now which formula we will use? We have a, s and u. So let's see, we have a, s and u. We can find v very easily. So therefore v square minus u square is equal to twice s. This is the formula. So we need to find v. So let's keep v square here. U square, u is 0. See, u is 0, so it is 0 square equal to twice a. Acceleration is 10 and s is 20. So we have v square equal to 2 2s are 400. So v is equal to root over 400, that is v equal to 20. So the final velocity will be 20 meter per second. Fair, it is very easy. So done, we have found the final velocity. Now we need to find in the second part of the question, what is the time that will be taken. So what is the time taken? Time taken means t. We have to find how much time is taken. So how to find? Now we have u, v, a, s, everything we have. So which formula to use? I want to find t. Let's use this formula, the easiest formula. So we have v is equal to u plus at. What is v? V is 20, u is 0, acceleration is 10 and t is the time. So that means 20 is equal to 10t. So what will be t? T will be equal to 20 by 10, which is 2. So that is time taken is 2 seconds. So that is how we solve this question. Very easy. You have everything given. You have to find v. You use this formula. Find v. Then you have found v. Now you want to find t. Use this formula and find t. Done. Very simple. Let's move on to question number 8. So 8 again we have a graph, but this time it is a simple graph. You don't have to worry about this. It is not as complicated as question number 6. So let's draw the graph. The graph is given something like this. Right? It moves up and then levels out. So what is it given? Okay, so it is given somewhere. The markings here are given as 2, 4, 6, 8. So it is 2, 4, 6, 8, and here we have 2, 4, 6, 8, 10. So we have 2, 4, 6, 8, 10, something like this. Okay. So it is 2, 4, 6, 8 and 2, 4, 6, 8, 10. What is this? This is our time. And that one is the speed. So this one is speed in meter per second. So time will be in second. So this is the graph given, this speed time graph. So the speed increases and then levels out. Okay. So what is the question? Find how far the car travels in the first 4 seconds. Shade the area on the graph that represents the distance traveled by the car during that period. So 4 seconds means up to here. So if it is up to here, what is the distance traveled? How to find distance from velocity time graph? You have to find the area of the triangle formed. So here we see, you can find a triangle is formed here. We need to find the area of this triangle. So area of this triangle will give us the, so I have shaded the region. So area of this triangle will give us the distance traveled. So what is the area or distance traveled means area of triangle. So distance traveled is equal to area of the triangle. So what is area? Half into base into height. What is the base? Base is 4. What is the height? If we look from here, I think from the graph we can see, actually my diagram is not matching. From the graph it matches to 6. In the graph this portion matches to 6. Okay, in the main graph. So this will match here. So 8 will come down somewhere here. Okay. So the graph should be something like this. Okay. So we have 6 here, so that means the half into base into height, so height is 6, okay, 6, so it is 2, so it is 12 meter. So the distance traveled is 12 meter, that means the area of this triangle is 12 meter, so the distance is 12 meter, half into base into height. I hope it is clear. So we have found the area, that is the distance. What is the second part? Which part of the graph represents uniform motion? The part from this position till the end. Why it says uniform motion? Because here we can see that the graph has become straight. Straight means the speed is not increasing anymore, the speed is not decreasing anymore, it is the same speed. Same speed means uniform motion. So if you have to write exactly the point will be from the time 6 second to the time 10 second. See, from 6, actually from the main graph you will get it, it is actually 6 seconds from where it starts to be straight. If you look at the graph in the book, let me add the graph here, you will see in the graph now that from 6 seconds to 10 seconds, it is actually a straight line. So that means that straight line is the uniform motion. If the graph increases, then it is increasing speed. There is acceleration, or there is acceleration is taking place. If the graph comes down, that means retardation is taking place, negative acceleration. But if it is straight, that means it is uniform speed. Okay, so uniform velocity is between 6 seconds to 10 seconds from the graph itself. So that is how we do number 8. Now number 9 is a very interesting question, that state which of the following situations are possible and give example of these. An object with a constant acceleration but zero velocity. An object is having constant acceleration but has been having no velocity. Is that possible? Yes, it is possible. Let me give you one example. So what is the example? I take a ball and I throw it up. So when I throw the ball up, what happens to the ball? This is the ball and I have thrown it up. The ball goes up, stops and then comes down, right? When you throw a ball up to catch it, you throw the ball goes up, stops and then comes down. So it stops and then comes down. So at this point, when the ball goes, it stops here and then comes back down. So at this point it stops. Stops means what? Velocity is 0. Now you will ask me, where is the acceleration? Now you must know that the gravity is always pulling us down with a constant acceleration, which is approximately 9.8 meter per second square. This is the acceleration gravity has on every object on the earth. Okay, this is Earth's gravitational acceleration due to gravity. This is the value, acceleration due to gravity, how much gravity forces an acceleration upon us. Okay, so when the ball is here, any object on the earth, means right now that I am standing here, the gravity is pulling me down with this acceleration. Just because I have the ground here, I am not going down. If there had been no ground, I would have fallen. Okay, that's why every time we jump, we fall down, and every time you fall down, your acceleration is this. So right now that I am standing here, the gravity is pulling me down, but I am not going down because I have the ground. So when the ball is here, gravity is pulling it down at this acceleration. So it is acceleration, constant acceleration of 9.3 meter per second square. But there is no velocity because it has come to a stop. So when a ball is thrown up and it stops at the highest point, at that point velocity is 0 because it has stopped, but the acceleration due to gravity is constantly acting on it, so there is acceleration. Okay, I hope it is clear. Very interesting thing. Next one is also very interesting. An object moving in a certain direction with an acceleration in the perpendicular direction, means if I am moving in this direction, a direction perpendicular to me will be the acceleration. What we generally see, that if I am moving in this direction, acceleration will also be in this direction, right? A car is moving in this direction, if it accelerates, it will go in the same direction. But the question is, the car is, means an object is moving in a direction, but the acceleration is perpendicular to this. How is that possible? That is only possible in case of a circular motion. So if a body is moving in circles, then its direction of motion and acceleration are always at 90-degree angle. So if a body is moving in this circle, so this is the direction of motion at this point, but the acceleration is always outside. It is like centrifugal and centripetal force. If you have studied that whenever a body is moving, its acceleration is always trying to go outside the curve. So the body is always trying to go out. As a result, the acceleration is actually in this direction. Although the motion is in this direction, the body is moving in this direction. So it will move like this. This is going to be the direction. Every point direction is changing, right? It is always moving in circles. So its direction is changing. and at every point the acceleration will be always 90 degree. Means at this point it is going in this direction, at this point it will be in this direction, at this point it will be in this direction. So it is always 90 degree to the direction of motion. So this is the only place where there is velocity in one direction, velocity is in this direction, but acceleration is always moving outward at 90 degree. So all these angles are 90 degree angles. Okay, so that is question number 9, and we are moving on to last question, that is question number 10. An artificial satellite is moving in a circular orbit of radius 42250 km. Calculate the speed if it takes 24 hours to revolve around the earth. So I am going to give you the idea how to solve this, because it is very easy. I am not going to solve, I am only going to give you the idea. Try it yourself, very easy sum. So what is given is that an artificial satellite moving in a circular orbit has a radius of 42250 km. So radius of the circle, this is question number 10, we have radius of circle equal to 42250 km. Okay, it takes 24 hours to complete one revolution. So distance traveled is one revolution, right? Distance traveled is equal to one revolution of the circle. So one revolution means what? If this is the circular path, that means it started from here, given one complete circle, ended here. So what is the distance covered? This is the circumference of the circle. One revolution means circumference of circle. You know the formula of circumference, right? Circumference is twice pi r. So 2 pi is 22/7. What is r? This is the radius, r. Radius is 42250 km. So from here you can find the distance traveled by the satellite, and the time taken is equal to 24 hours. So here we have the distance in kilometer, here we have the time in hours. What we need to find? Calculate the speed. So therefore speed equal to, we all know, distance by time. So you will find a distance here, put the distance, time is 24, you will get an answer, whatever the answer is. So try this yourself, very easy sum, speed equal to distance by time formula. So here we have come to the end of all the sums, starting from question number 4 to question number 10. I hope you have understood. If you have not understood, ask me directly, I will explain it to you again. Okay, so please go through the video. If you have not understood one sum, recap to that position, play it again, see if you understand. If you don't understand after 2 or 3 attempts, then give me a call. Okay, so thank you everyone for watching, and until next time, cheers.